if synchronous motor is not self-starting, then let us see how to start the synchronous motor in this topic named procedure to start synchronous motor. Now let us jump directly to the some procedure steps so that you can easily understand how to start the motor. Okay. So initially we all know that we have to give three-phase AC supply to the three-phase winding, that is to the stator, which produces RMF, that is NS, in the stator part. Next, now what we will do is, instead of giving DC supply to the rotor, first what we do is, first we will drive the rotor by some external means, and external means in some in sense it can be you can rotate manually by hand to that synchronous speed, or else you can connect or couple a rotor with some single phase induction motor or DC shunt motor. You can couple to that, or you can couple DC engine also, so that the direction of the rotating magnetic field as well as the direction of the prime mover coupled to the synchronous motor is same, and we will rotate till the rotor speed reaches the synchronous speed. Okay. Now once you rotate the rotor to the synchronous speed by some external means, now what I'm going to do is, now I'm going to supply the DC to the rotor part. So when I give supply to the supply to the field winding, that is DC supply to the field winding, so that will cause appearance of or appearing of poles or rotor poles over the rotor. Now as I told, we are considering two pole synchronous motor, so that's why the reason we get two poles on the rotor part also. Okay. And again, so due to this, what happens? Due to the production of the poles or appearance of the poles over the rotor, so the rotor is physically rotated at the same speed as the rotating magnetic field. So there are two fields now here. One is main field produced due to DC supply to the rotor. The other one is rotating magnetic field produced on the stator or produced by the stator due to the supply of AC supply. So these two fields will interact with each other, and that's thus causing torque to rotate the motor at the synchronous speed. Now you can see in the fourth step, at a particular instant, you can say some after few seconds, or you can call, so both fields, that is RMF as well as your main field, will get what? Magnetically locked. So that's why what happened, the stator field will pull the rotor field into synchronism. What actually they're trying to say is, the speed of the RMF as well as the speed of the rotor will get magnetically locked. Both, there will be no any relative motion between those two speeds. Again, the slip will be zero there. So that's how what happens, rotor gets pulled into synchronism. Now the motor will run into the run in the synchronous speed. Once the motor catches the synchronous speed, that can be seen verified by the your tachometer. Now what you can do is, you can remove the external means whatever we have coupled, no prime mover, like it may be your diesel engine, it may be your DC shunt motor, it may be your induction motor, whatever you have coupled, now we can remove, and now the motor will still continue to rotate in the clockwise direction, whatever, clockwise or anti-clockwise, depending upon the phase sequence you have applied, but it starts to rotate at the synchronous speed. Okay. So this is how the procedure to start. It's just a general procedure. Again, we have different procedure for different types of synchronous motors. This is a general procedure to start the synchronous motor. Now let us see the methods of starting synchronous motor. You can see they have described four methods. One is using pony motors. Pony motors, it may be your induction motors. Okay. Using damper winding. Damper winding you are going to place over the rotor, so that your motor will run initially like induction motor. So such motors are called as synduction motors. Yes, I repeat, synduction motors. Combination of synchronous as well as induction. We are calling it as synduction motors. Where the damper windings or damping windings are used placed over the rotor. Second one is as a slip-ring induction motor, as you already discussed what slip-ring induction motor is in your earlier class. The fourth one is using small DC machine coupled to it. That's what I'm saying. You can couple DC shunt machine also to the rotor, so that initially it can be rotated at the synchronous speed. Okay, these are all the four methods which we shall discuss now. First one is using the pony motors. Here, like I said, the pony motors may be your it can be type of your induction motor, a small induction motor which is externally coupled to the rotor of the synchronous motor. So using that induction motor, I will make my synchronous motor to run at the synchronous speed. Once my motor achieves the synchronous speed, what I'm going to do is I'm going to supply the DC supply to the field winding so that the stator and rotor will get magnetically locked, so the motor will reach the synchronous speed. So after that, what I can do is I can remove the coupling done to the rotor of the rotor of the synchronous motor, so I can decouple the pony motor or induction motor. Okay, this is how we are going to run the synchronous motor using the pony motors. The second one is damper windings. See, this is damper windings. Remember, this such type of motors are called as induction motors. So apart from my existing field winding, I will place some more windings over the rotor. I will cleverly place the damper winding such that it will appear like a cage like structure. Hope you have studied the squirrel cage type of induction motors. Similar ways, I'm going to place some more windings with having some skew angle and all over the rotor, over the field winding of the existing field winding of the rotor, in such a way that initially your motor will run like an induction motor, and after when it runs like induction motor, when it is almost or approximate equal to the synchronous speed of the synchronous motor, I'm going to supply the DC to the field winding. When I give DC supply to the field winding, what happens? The poles will start to appear over the rotor, and due to this, what happens? There's a magnetic locking between stator as well as the rotor. Once the magnetic locking occurs, what you can do is you can remove the DC supply, but still we keep the DC supply always to the rotor part so as to change the excitation, so your motor can run as synchronous condenser. Okay, and remember here one thing, that without any external means supply or external coupling of DC shunt motor or prime mover or any diesel engine, the synchronous motor will start. Okay, that is the only reason, because of the damper winding. So initially your motor runs as an induction motor with certain slip. Okay, with certain slip. So when I give DC supply, then there will be no any relative motion. Then there will be no any relative motion between the stator as well as the rotor. So if there is no any relative motion, means there is only induced EMF in the rotor part, and the EMF induced will be zero due to the from the stator. But due to the magnetic locking as well as the application of the field winding, this supply to the field winding, the motor will start to run. Okay, at the synchronous speed, and you can continue the supply of the DC to the field winding so as to act your synchronous motor as synchronous condenser. Okay, so as to control the power factor in the power system. Okay, there you can see the damper winding is short circuit just like your induction motor, and it draws we know that due to the damper winding, as it is of very less resistance, it draws high current initially. So to eliminate high current, what I'm going to do is I'm going to use starters. We know that what starters play role. Starters will limit the initial current so that thus preventing flow of high current initially into the stator part. Okay, now third one, that is as a slip-ring induction motor. So you can see here the stator is star connected here, three-phase AC supply I am given. This is the rotor part, which is the right one, and this is your shaft. Okay, and you can see that the rotary also here connected in the star fashion, but it is directly connected with a strong connection they have made to the connection to the slip rings, where you can consider this as R, and this is considered as Y, and this is considered as B. They have directly connected here with the strongly connected, no any connection with the help of brush and all. But you can see the output of this three slip rings, and these are the slip rings, will be always rotating with the shaft. And the slip rings, you can see there are three brushes and one brush. Again, from one brush we're getting one out of it we're getting one wire. So totally there are three wires out of the three brushes, and you can see that two wires are connected to the negative supply of the DC, whereas the one wire is connected to the positive supply of the DC. Okay, so initially what we do is, initially this three, whatever triple pole double throw switch is there now, initially I'm going to keep at this as well as this position. So this is all done before applying any DC supply. So this triple pole double throw switch will be at this position. So why I'm doing this, all this thing is because so as to limit the starting current, and we know that this is the rotor resistance control method, where you can control the rotor resistance so that you can increase the initial torque, and also you can limit the initial starting current. So these are the two things you're going to get it as advantage by using the rotor resistance method. First one is you can increase the starting torque, whereas you can decrease the initial starting current. So these three switches will be at this position. So once I give supply to the stator, it creates RMF. Now what happens? Now the rotor will start to rotate in the direction of the stator field, and due to the addition of the resistance, so what happens? It is getting high starting torque, whereas the current is also limited. Okay. Now what I'm going to do is, once motor pickups say around say 70 to 80% of the picks up the rate 70 to 80% of the rated speed of the synchronous motor. Now what I'm going to do is, now I'm going to switch this triple pole double throw switch from start, before it was here, to the run. Now I'm going to give to the DC supply. The reason I'm going to give to the DC supply is to what? To make the motor to run at the synchronous speed. If I don't want the motor to run as DC supply at the synchronous speed, means then there is no need to give the DC supply to the rotor. But once the motor attains 70 to 80% of the rated speed, I'm going to pull this triple pole double throw switch to the run position, so that supply is fed to the rotor part, and due to the supply fed to the rotor part, DC supply to the rotor part, field winding, it gets its own poles, and these poles as well as the stator poles will get magnetically locked, and thus there will be no any relative motion between the stator as well as rotor, and the motor will always start to rotate in the synchronous speed. Okay, this is how we're going to start the synchronous motor by using slip-ring induction motor. Okay, this is a slip-ring induction motor, but this setup should be there in the lab or anywhere else, so as to run the motor as the synchronous speed. Initially it runs as an induction motor. Don't forget, initially it runs as induction motor with certain slip. As soon as I put a TPDD switch over here, the motor runs at the synchronous speed without any slip. Now fourth method is using small DC machines. Like I said before, you can couple any constant speed machine. Here we are going to couple what? The DC shunt motor and not DC series motor, as we know that characteristics of DC shunt motor, it is always having a constant speed. Okay, now I'm going to couple a small DC machine, so that the DC machine rated speed as well as synchronous speed are both same. So once I do so, the rotor starts to rotate, and again now what I'm going to do is, then again same procedure, again I'm going to excite with certain DC supply. After getting excited, what happens? The poles will start to form, or poles will appear on the rotor, and once poles appear the rotor, what happens? The rotor poles as well as the stator poles will magnetically get locked eventually, and once these two poles, that is stator poles as well as rotor poles, get magnetically locked, then what happens? The motor will start to rotate in the synchronous speed. And again, once the synchronous speed is achieved, you can decouple the DC machine. Okay, or else the same DC machine which I have coupled to the synchronous motor will act like a even DC generator as well, like a role of exciter, as we know that synchronous motor need a DC supply to get magnetically locked. So the same DC machine can be utilized to supply DC to the rotor of the synchronous motor, so that it gets magnetically locked. Okay, instead of decoupling, you can do that also, rather than giving DC supply somewhere else, the same DC machine which I have coupled to the synchronous motor, it will generate what? DC supply to the synchronous motor. Okay,